So in order to send these over to Unreal, we're going to want to make sure that we're setting attributes on the geometry that Unreal is going to be able to understand and interpret via the Houdini engine import. An alternative would be to export each of these individual meshes as an FBX file on disk or any other geometry format, or perhaps USD. But I like working with the Houdini engine importer because it comes with a few perks, such as being able to set properties on the static meshes, assign materials, and various other things. So first of all, we're going to want to loop over each of these clusters so that we can set cluster-specific attributes. So we can say for each named primitive, not for each connected piece, and for each named primitive, the named primitive is going to be what's the cluster. And right now it says this attribute does not exist, and that's because when we copied the cluster and the color, we copied them as point attributes. So we're going to grab the CD and cluster, and we're going to promote from point to primitive, like so. In fact, let's just bring over the cluster attribute. Then we're going to reset that cached pass. And why is that not working? What have I messed up? So point to primitive cluster, for each named primitive, invalid attribute, reset cache pass, doesn't want to work. It's going to disable and re-enable it. Sometimes Houdini can be a little bit funny like that. There we go. So now you can see we have 99 runs, and each of these is a single kind of element now to send over to Unreal. I think I want to reduce the overall memory somewhat, so I may do one last little kind of poly reduce step as well. So we're going to go ahead and do poly reduce inside of this loop, and let's say we want to equalize the lengths quite a lot because we want to have even triangle sizes for Unreal. And we're going to set the percent to keep to 50. There we go, maybe even 25. And remember, we're relying on nanite displacement to really sell these rocks up close. We only care about the volumes really coming over from Houdini. And since we're running over these things one by one again, let's put this inside of a compile block as before. That's annoying. That would go away. There we go. Set this to manual. Hook this up. And we're going to say multi-thread. On mouse up. We'll see that the poly reduction happens very quickly. There we go. So that's happy little rocks now. Kind of quote Bob Ross. And not too much of a difference in terms of detail and silhouette. I mean, we've lost some interest, but once again, nanite displacement is going to do a lot of work here. And if we look at the information, we can see that this is now 272 megabytes. That's actually slightly misleading. It's going to be even less than that. Go ahead and delete all of the attributes because we don't need anything apart from, in fact, if we delete, it'd be easier to delete non-selected because we're only going to keep the normals on these rocks. There we go. Yeah, so slightly less once again. And now in order to get Unreal to see these each as their own kind of mesh, rather than kind of one giant mesh, we have to pack them. So packed geometry inside of Houdini is somewhat like instancing inside of Unreal. And when we pack them like this, basically what we're saying is instead of now representing this as individual polygons and points, Houdini is going to see each of these groups as one piece of geometry. So you can see there's only 100 primitives and 100 points. So somewhat like when we were dealing with volumes, there's only now 100 elements. And this essentially is telling Houdini to tell Unreal that each of these should be imported as a separate object. Okay, so next up, we want to do things like deal with assigning different Unreal kind of properties that are important. So we're going to put down a wrangle, and this wrangle is going to be a primitive wrangle that's going to run over the geometry before it's packed, because material assignment happens at the kind of polygon level or primitive level rather than at the global level. What we're going to do is we're going to say S at Unreal Material. This is just something that Houdini knows how to deal with when you use the Houdini importer. I'm going to say CHS Material Path. And this little CHS string just allows us to then have this be a variable that we can promote, like so. Okay, so this allows us to just say what material is going to be assigned to which cluster. Next up, we're going to want to say that nanite should be enabled by default on import. So we can set up this line, Unreal Nanite enabled equals, and then we can say true or false. We could set all of these globally as well, rather than in this loop, but there are certain things that we're going to be defining per object, so it just kind of makes sense to keep it all together. Next up, we want to choose a bake folder. Where are these rocks going to be sent inside of Unreal's content browser once they've been made? So we're going to say chs bake folder. Okay. Maybe we can set to manual while we do this. We also want to pick a name for each rock. So we're going to say s at Unreal output name, and here we can just once again have a string that's going to be the name, so this will be something like rock, and then we actually want to suffix that with the number of the rock. So that's going to be plus, there's going to be an underscore and then a plus, and then we're going to say itoa, which is converting an integer to a string, and say I at cluster, because we know that we have the cluster attribute on the primitive. Okay. All right, so that's all looking pretty good, I think, at this stage. There's more things that we can set than that, many more, so I encourage you to go to look at the Houdini engine docs for Unreal. But for now, let's leave it there, and then let's set up all of these paths to be the correct values. So go on mouse up, let this all cook. I'm going to pop over to Unreal, and we're going to decide where we want these things to get set up. So inside of Elderwood, you should probably make a folder called Meshes, and I'm going to make a new folder called Cliffs, and I'm going to go ahead and copy a material that exists elsewhere into this Cliffs folder. So we're going to say copy here, and we've got this this material now inside of this Meshes Cliffs directory. So now I can go and right-click the Cliffs folder, and we can, I believe, copy the path, go over to Unreal. I'm going to say this is the bake folder. Okay. Next up, we're going to go inside of the Cliffs folder and select the Cliffs material. I'm going to, once again, copy the path, and we're going to set this. Actually, let's copy the reference instead. Set this in the material path string. And then finally, we're going to say Elderwood Cliffs. That's the name of the rock. And then we're going to see that the Unreal output name is going to get suffixed with an underscore and then the cluster ID. And we can verify that all of these attributes have been correctly set. If we go to the attribute wrangle and click spreadsheet, before the pack, we can see that we have all of these living on the primitives. So these tend to be attributes that you would set on the per primitive basis. In case you wanted different pieces of geometry to have an analyte enabled or not, if you wanted to send different geometries to different bake folders, or if you wanted to send different geometries, say they have different materials and so on. Okay. So there are things you can set at the global level as well via a detail wrangle, which we may come back to. But at least for now, what we're going to do is just going to go and see whether we're getting anything like what we want. So we're going to go ahead and say rock geometry output. And we can call this basically whatever we want. So I'm going to call this Elderwood Cliffs Workshop .bgo. And now, by default, you might have noticed it was .bgo.sc. SC just means it's a compiled version of the BGO. I don't really care. I don't need to save any space. I just want it to export and import quickly, so it's better to have the uncompiled geometry for that. And now this export with this single BGO file contains all of the information that is required by... oh, where are they? Let's go ahead and try and save that to this once more. Elderwood Cliffs Workshop. There it is. I must have just missed it. And this single file contains all of the information that's needed by the Houdini engine to instruct Unreal about how to set this up. You can see it's just a 30 megabyte file, which contains all of the cliff geometry for this entire section of landscape.